ठीक है. So last time we had just started with the center of mass of continuous objects. ठीक है. Laminar objects, they are also called as laminar objects, you can say. ठीक है. Continuous objects, or you can say big mass. ठीक है. Other than point masses, combination of masses, you can say. ठीक है. So we had just written, ठीक है, that the value of xcm, ठीक है, that can be calculated how? By integration of x dm divided by integration dm. ठीक है. This was how we had defined the center of mass of our continuous objects, x coordinate of the center of mass of the object. ठीक है. So in that same manner, you can define y coordinate also, y cm of the object, by replacing x with y, y dm upon integration dm. ठीक है. It is simple. Instead of keeping the rod along x axis, keep the rod along y axis. So instead of getting x coordinates, now you will start getting y coordinates. Similarly, if you have z coordinates, ठीक है, zcm, you can write zdm upon integration dm. ठीक है. So in this manner you can find out the coordinates of your continuous mass, है ना. अच्छा. Now suppose, है ना, suppose you have a radial object, like you have a sphere or a hollow sphere, you have a solid sphere or something like that. You have, ठीक है, you have a spherical surface, spherical object, and the the distance is now changing radially. ठीक है. Instead of changing along x, y and z individually, now the distance is changing radially, है ना. So in that situation, in that condition, what you can do is you can calculate the value of rcm, ठीक है, the radial distance from the center of the mass. ठीक है. From the center of your system, or you can say, ठीक है, from the center of your system, the radial distance of the center of mass can be calculated. ठीक है. अच्छा. So what is that radial distance? How to calculate that radial distance? ठीक है. So that is again the same. ठीक है. That is again having the same method, that you integrate r dm. Now this time, earlier we were integrating x coordinate, y coordinate and z coordinate, but since we are calculating the radial distance of the mass, ठीक है, since we are calculating the radial distance of the mass, we will multiply it with the radial distance of the dm mass. ठीक है. I told you what is dm, a very small portion of the complete mass. ठीक है. A very small portion of a complete mass at a distance r. ठीक है. So if we integrate r dm, है ना, so it will give me the radial distance of my center of mass. ठीक है. We will see examples of these. Don't worry about it. ठीक है. So let's start with examples then. ठीक है. These are the basic formulas which you have to remember for continuous masses, है ना. अच्छा. Let's see examples. ठीक है. Suppose I have to find out the center of mass of a square plane like this. ठीक है. First let's talk about rod only. ठीक है. Suppose I have a rod and I have rod of length L and mass m. ठीक है. Total mass is m and its length is L, and here the, you can say, the mass density, ठीक है, rho, ठीक है, mass per unit volume is constant. ठीक है. It's not constant, you can say uniform. ठीक है. So if your mass density is constant, it is uniform, then your all the dms, ठीक है, all the dm which we are going to use to calculate the center of mass, ठीक है, they will have all of them will be having the same mass, approximately the same mass. ठीक है. They are very small values, So it won't have any it won't have much of a effect, okay, while calculating dm. So let's see how to calculate when you have a continuous mass, okay. Point mass is very easy, okay. Directly write the x coordinate, y coordinate, you will have the answer. But when it is a continuous mass, you have to follow certain steps, okay. Those steps you have to keep in mind. Acha. So let's see those steps. Okay. What we need is, first of all, this rod is along x-axis. Okay. So I will obviously get the value of xcm only. Okay. If you calculate ycm, it will be 0. If you calculate zcm, it will be 0. Okay. You can determine already that. है Because the object is in x-axis, uh, the coordinate of center of mass will be along x only. Okay. That is understood. Now, how to calculate this? Okay, it is simple. Integration x dm by integration dm. This is what we have to do. Acha. What we do is, we at a distance x, we take a very small mass dm. Okay, we consider a very small mass, very small element of a mass, that is dm. Okay, this is dm is also called as the elemental mass. Okay, it is also called as elemental mass. So we take this elemental mass and try to calculate the value of dm. Okay, we try to calculate the value of dm. Now, how to calculate dm? Just see. If I am talking about the thickness of this dm mass, okay, let's remove this. If I am asking you that at distance x, this dm mass which I have considered, what should be its thickness, what should be its length, you can say. Okay. So you can say that, sir, since it is a elemental mass, since it is a very small mass, its length will also be very less, its length will also be very small, negligible almost. Okay. So you can say कि sir, it can be dx. Simple. है ना. Very small mass will have a very small length. ठीक है. Longer rod will have a longer length, longer mass will have a longer length. ठीक है. Simple. You can understand by that logic. ठीक है. So what we did is, we went till a distance x, and at x position we took a dx length of mass. That dx length of mass had a elemental mass of dm. ठीक है. अच्छा. Now now since mass density is uniform, ठीक है, what I can use is, I can apply my unitary method over here. ठीक है. That for length l, the total mass is m. Yes, any doubts? ठीक है. For length l, the total mass is m. So for unit length, how much mass should be there? M by l. That should be m by l mass. Acha. So now how much length do I have? I have dx length. So for dx length, my mass should be m by l into dx. Unitary method. Okay, I will have to multiply it with the length which I am taking. Okay. So this mass, this value which I am getting, is equal to your dm. Okay. This will be your elemental mass. The formula for elemental mass, you can say the value of elemental mass. Again. So now I have calculated the value of dm. So what you can do is, you can just start replacing it over here. So what you can see is that it is integration of x. Let's replace dm, m by l dx upon integration of m by l dx. Okay. Acha, integration is there, so you need limits also. So see, your x, okay, your x will be starting from this position. Okay, you will take element over here, here. Till here you will be taking elements. So your x is starting at x equal to 0, and your x is ending at x equal to L, because beyond that there is no mass, so it makes no sense. Okay, you cannot write a value of dm for x greater than L. Okay, so if you cannot write anything for x greater than L, so x will end at x equal to L. That means the limit of x, okay, the limit of upper limit of x is L, and the lower limit of x is 0. Okay, because below 0 also, in the negative side also, there is no mass. Okay, your mass is restricted between 0 and L. Okay, so the limits are from 0 to L, 0 to L. Okay, limits of x, because you are integrating with respect to x, you can see that. Okay, now let's integrate this. Okay, if you integrate this, you can see that m by L is a constant which will come out of integration in numerator and denominator both, so it will cancel out. Okay, once it cancels out, you will have integration x dx upon integration dx from 0 to L, 0 to L. Okay, the value of integration x dx is x square by 2, x square by 2 from 0 to L, divided by integration dx is x from 0 to L. Yes. Okay, so when you replace these values, you have a known value of center of mass, that is L by 2. Okay, replace these values and you can calculate it, that the xcm will come out to be L by 2. Center of mass is at a distance of L by 2. So this is a known quantity, so it is just for making you used to the method, used to the procedure. Okay, that if some random, if in some case some random shape comes, so it is not ki you just leave it there and come. Yeah, solve it, try to solve it. Okay, the method is important. Replace the limits, na, replace the limits. Okay, here see, if you replace the upper limit, it will be L square by 2 minus 0 square by 2 upon denominator. If you put the limit, it will be L minus 0. So 0 square by 2 is 0 only, and 0 is 0, so this will be L square by 2 upon L. L and L will get cancelled, you will have L by 2. Okay, it is simple. Yes, yes. Okay, so this method is important. Okay, I also knew, you also knew that the answer for this will be L by 2. Okay, everybody knows that the center of mass of a uniform rod is at a distance of L by 2. Okay, but why did we solve it? So that you can understand the procedure, you get used to the procedure. Okay, so that is important. Okay, so write this, and then we will move on to the other type of question. Just a minute. And okay, so I guess you have written this. Okay, just a minute. Mhm. ठीक है. So this procedure which we have done was for uniform rod. Okay. Now let's see what should happen, what will happen if my rod is not uniform. Okay. The mass density here I have written is uniform. Okay. Uniform means every dm. Suppose even if I take dm over here, the value of dm over here will also be m by l into dx only. Okay. If I take dm over here, still its value will be m by l dx only, it will be same. Okay. But what will happen, what should happen if my mass density is varying? Okay. If my mass density is varying, so again let's see x and y axis. Okay. I have a rod, the length is l, but now this time its mass density is given to us as uh, let's see, let's keep it a bit simple. Okay, something like this. Okay, suppose the mass density of the rod is something like this, m naught by l into x. That means see, m naught and l are constants. Okay, m naught and l are constants. So basically, if you see it in terms of mathematics, okay, so it is what it is. Density is equals to some constant times x. Okay, some constant times x. As the x keeps on increasing, as the x keeps on increasing, your mass density also keeps on increasing. Your mass density also keeps on increasing. Okay, let's not write it as rho, write it as lambda. Okay, write it as lambda. I will tell you what is lambda and all. Okay, lambda is linear mass density. Okay, I think you must have done this, but if you have not done it, okay, I will tell you again, no problem. Okay, lambda. So lambda is m naught by l into x. So you can see here, as you are going further away from the origin, the unit mass, okay, the mass of a unit length of the rod is increasing. That means what? If I am at this location, if I am taking a mass dm over here, suppose dm1, and I am taking a dm element over here, dm2, then the value of dm2 will be greater than dm1. Why? Because the density for this, the lambda 2, is greater compared to lambda 1. Okay, lambda is what? It is mass per unit length. It is mass per unit length. Since the lambda, you can write mass as lambda into length. Okay. Now see, length of both the elements are same, approximately dx and dx only. There is no difference in that. But the value of lambda 2 is greater than lambda 1. Hence, the mass also is greater for second element. Okay. So in this situation, we cannot apply uniform. We cannot apply your linear formula. Okay, not linear means unitary method. Sorry. Okay, here we cannot apply unitary method. Unitary method is for something which is proportional. Okay, it is constant or uniform, you can say. Okay, everywhere that should be applicable. That for unit length, the mass is coming out to be constant for everything. Okay, we can use it only where uniformity is there. Okay, so here we cannot use your unitary method for calculating the value of dm. Okay, so let's see what we can do. Still the value of x cm will be that only, x dm upon integration dm. What we have to do is find the value of dm in general. Okay, in general means what? That suppose I am at a distance x, and here I take a element, small element dx. This small element dx will have a mass dm, and so I have to find the mass of this small element. dx. Okay. So how to find this now? Just see. When I wrote lambda, okay, lambda is written as mass per unit length. Okay, mass per unit length. Suppose the mass is not uniform, like in this case, I can write lambda as dm by dl. I can write the um, uh, uh, lambda for the rod as dm by dl. ठीक है. It is same as your acceleration. ठीक है. If you want instantaneous values, you write dv by dt, and if you want the average value, you write delta v by delta t. So it is something like that only. ठीक है. When the mass is uniform, when the mass is equal everywhere, ठीक है, you use m by l. When it is varying, you can use dm by dl. ठीक है. So what I can do here is I can write dm as lambda dl. ठीक है. I can rearrange it. ठीक है. I will rearrange dl into dl to the other side. So as and when I arrange it, I will have dm is equals to lambda dl. Now lambda is given to me as this function of x. So what I can write? I can write it as m naught by l x. This is the value of lambda. And what is dl? dl is the very small length on the rod. The very small length on the rod which we are considering is dx. It is dx. So this will be replaced with dx over here. Okay, so dm in this case is coming out to be m naught x by dl into dx. Is this clear? Is there any doubt in this? है ना? ठीक है. So this is the basic. ठीक है, you have to keep these basics in your mind, है ना, every time, because see, these are just the standard methods. These are just the basic methods. ठीक है, this will be used everywhere. ठीक है, that is why I am taking so much time. Don't worry about it. Now replace this dm over here. ठीक है, here and here. So what we get is integration x m naught by l x dx divided by integration m naught by l x dx. ठीक है. So this is the formula which we are getting, which we have to integrate. This is the relation which we are getting to integrate. Something like this should be the answer. I also don't know. I just made it up, so I will also have to check. Acha. Now see again the limits of x. Again the limits of x. Limits of x are again defined between, confined, you can say, between x equal to 0 to x equal to l. Okay, because your rod is between 0 to l, your limits of x is again 0 to l. 0 to l. Okay. Again m naught by l is constant. It will come out of integration in the numerator, in the denominator. It will get cancelled out. M naught by l will be cancelled out. So what you are left with? You are left with integration 0 to l x square dx divided by integration 0 to l x dx. Okay. Now if you integrate it, it will be x cube by 3, limits from 0 to l, divided by, in the denominator it will be x square by 2, limits from 0 to l. Okay. Now replace the limits. L cube by 3 minus 0 cube by 3 upon, in the denominator if you replace the limits, l square by 2 minus 0 square by 2. So this will be l cube by 3 upon l square by 2. L square l will get cancelled. So this will value will be 2 by 3 l. That is correct. Okay. So xcm which we had, which we wanted to calculate is 2l by 3. So you can see here that the center of mass has shifted towards right. Just see here. X was there, okay, and I had introduced m naught l by x in dm. Okay, in dm there is x, another x is there, na? In the formula already there was a one x, and in dm also there is another x. So x into x will be x square. Okay, see it like this. ठीक है. So this is the, this is the method, this is the general step, this is the general way to calculate center of mass of any object. ठीक है. So just write this. Then I will calculate one more shape which is important. Okay, after that, the center of mass is, you have to remember. ठीक है, written. ठीक है. Now see, uh, in most of the cases, ठीक है, you will have general shapes and figure only. ठीक है, general shapes and figure means like you will have a square plate, you will have a circular ring, ठीक है, complete circular ring, you will have a cylinder. ठीक है, for all these shapes, ठीक है, it is not like that you will go on starting integrating for everything. ठीक है, because you don't have much time. ठीक है, you have very limited time to solve the questions, around 1.5 to 2 3 you can say max. ठीक है, 3 minutes for some questions. ठीक है, so that is a very tight situation for deriving formulas in exam. So what we do is we try to remember the, ठीक है, we solve the results. ठीक है, using this method we solve the results of the standard shapes and figures. ठीक है, standard shapes means you have a ring, you have solid sphere, you have hollow sphere, you have solid cone, you have hollow cone. All of these shapes are normally used while making questions of center of mass. ठीक है, so we remember the results of those shapes. ठीक है, those basic shapes, standard shapes, we remember the results, है ना, so that you can easily use it in exam, है ना. अच्छा, so just before making that table, ठीक है, I will make a table for that so that you can remember every values of center of mass. ठीक है, but before that let's take another example which will be there in the table. ठीक है, that is find the center of mass of a half ring, a semi ring, you can say, not half ring, semi ring, semi ring from the center of the ring. ठीक है, this question, this is the question we have to solve. Now see, if I had the complete ring, suppose this is the xy axis, and I have the I have the complete ring over here like this. This is my complete ring. Okay. If I have the complete ring, then the center of mass and the center of the circle is the same. Okay. Center of mass is over here only. Yeah. But now, since it is only a half of the ring, okay, since it is only half of the ring, you can imagine that the center must have shifted from this position over here. Okay, center of mass. CM is center of mass. CM is center of mass. I told you in the last class, I guess, that I will write CM for center of mass. ठीक है, CM is center of mass. No problem. ठीक है, अच्छा. So, in case of complete ring, in case of a full ring, the center of mass and the center of circle are same. ठीक है, center of mass and the center of circle are same. But in a semi ring, in a half ring, ठीक है, the center of mass and the center of circle are at some distance. ठीक है, they are at some separation. है ना? अच्छा. Now it is very important you understand how the center of mass works before that. ठीक है, suppose just for example, ठीक है, this is side information. ठीक है, this is not there in the solution of this problem, but this is side information. It can help somewhere. ठीक है, suppose on a straight line I have two equal masses, two equal point masses m and m. ठीक है, suppose I have two equal point masses m and m. They are at some separation d. ठीक है, then what will be the center of mass? It is logical, it is understood. ठीक है, you write the formula and calculate all of that. ठीक है, that will be coming out to be the center of mass at a distance of d by 2 only. ठीक है, when equal masses are there, equal point masses are there, the center of mass will be at the center of them. ठीक है, it is common sense, you can say.
Sir,
okay, it is. Yes,
could you please scroll up?
yes. ठीक है, now if just imagine if by some manner, by some way, I have increased the right hand mass from m to 2m. ठीक है, I have increased the right side mass from m to 2m, and this was the previous position of your center of mass. Now the new center of mass will be shifted in which direction? To the right or to the left? Anybody? To the right or to the left?
Right.
To the right, to the right. ठीक है, you can understand the logic behind it, है ना? The center of mass will be shifted towards the right because more mass is there on the right compared to left. ठीक है, on the right there is 2m mass, on the left there is only m mass. So it is understandable that the center of mass shifts towards the right. ठीक है, it is something like that when you try to balance a pen on your hand. ठीक है, if the cap is on, ठीक है, you have to shift your hand towards the cap, है ना? And if there is no cap, then it is at the center only. ठीक है, it is something like that. You must have done such kind of thing. That is why I was giving that example. ठीक है, so that is understandable. ठीक है, instead, now suppose if instead of right hand side, my left hand side had 2m mass, my left hand side had 2m mass and right hand side had m mass only, then the center of mass would have shifted towards left. Center of mass would have shifted towards left. ठीक है, so this logic, ठीक है, this this feeling, you can say, this logic of shifting of center of mass is natural. ठीक है, so here also see earlier when the complete ring was there, you can say that m by 2 mass and m by 2 mass was there in both the sides, that is upper half and the lower half. ठीक है, that is why the center of mass was at the center, exactly between the two. ठीक है, but when I removed the lower half, upper mass, upper part, ठीक है, the area above the x-axis had m by 2 mass, but below it had become zero. So what you have done is you have reduced the mass on the lower part. ठीक है, if you have reduced the mass on lower part, it is necessary, it is obvious that the center of mass will shift towards the upper half of the mass. Okay, it will shift towards the upper half of the mass. Hence, the center of mass will be shifted in the upward direction towards the center, towards the ring, you can say. Okay, there is a common confusion. Many times, many students have confusion that कि sir आपने जो CM निकाला है, the value which you have calculated, whether it is in upward direction or downward direction. ठीक है, whatever value we will calculate, that is a different thing. So that is why I am clearing it beforehand only. ठीक है, many of my previous students have asked this. ठीक है, so that is something which is logical. ठीक है, you have to understand that the center of mass will be in the upward direction only, or you can say towards the ring only. ठीक है, if the ring is in the downward direction, then from the center it will shift towards the down only. ठीक है, it is not कि ये बिल्कुल upwards ही होगा every time, है ना. So use some logic, use some common sense also, you can say. ठीक है, but try to analyze the situation. ठीक है, try to analyze the problem, है ना. Don't just randomly remember anything. ठीक है, so that is understood. ठीक है, that is why I am clearing that kind of doubt over here. ठीक है, it is a very minor doubt. ठीक है, it is a very common doubt, but ठीक है, it is a doubt. ठीक है, so always remember the center of mass for any half of the thing. ठीक है, if it is a semi ring, it is a hemisphere, or it is a half cut cone. ठीक है, anything is there, if it is semi and it is half or anything, ठीक है, always the center of mass will shift towards the mass, towards the shape. ठीक है, it cannot be away from that shape, है ना. You have to remember this. ठीक है, so this was just a general idea. ठीक है, general you know the values which you have to, direction which we will see. Acha, now let's talk about the calculation of center of mass. This is x, this is y.
Scroll up. Yes, sir, thank you.
ठीक है, so this is the half ring which I have. ठीक है, let's consider its radius to be r. ठीक है, and the center of mass is somewhere here. That is a different thing. ठीक है, we will get to that afterwards, है ना. Now see here you cannot integrate. ठीक है, you won't be able to integrate your values by calculating in radial direction. ठीक है, why? Because see, let's assume that the total mass of this ring is m. ठीक है, let's say that the total mass of the ring is m and its radius is r. Now what we do, ठीक है, there is a certain method to solve this. That ultimately what we have to do, we have to find dm. ठीक है, ultimately what we have to do is we have to find dm, that is integration x dm upon integration dm. So what we do is we try to find the value of dm. ठीक है, so to find value of dm, what we do is we move a angle theta from the x axis in the upward direction. ठीक है, we move at an angle theta in the upward direction, and from this theta we move a d theta angle, move theta angle forward in this direction only. ठीक है, so this d theta angle, ठीक है, this separation, this d theta separation is creating a small element over here. ठीक है, it is creating a small element over here. ठीक है, it looks a bit big, but in actual it is very small. ठीक है, it is very small. Now if it is very small, can I consider this thing, ठीक है, this part, red part, to be my elemental mass? Can I consider it? Obviously I can consider it. ठीक है, why I can consider it? Because it is a very small mass. It is a very small element of a mass. ठीक है, अच्छा, now I have the element, ठीक है, I have to calculate the values, ठीक है, I have to calculate its values of x and y, ठीक है. So uh, how we can find the value of dm first of all, ठीक है. Dm means the mass of that small element, ठीक है. So for that again it is a uniform rod, ठीक है, sorry, it is a uniform ring, so you can use unitary method, ठीक है. Unitary method, by unitary method I mean that for 2 pi, sorry, for pi r length, ठीक है, that is the circumference of the ring, because mass is there only on the circumference, ठीक है, it is a ring, so mass is there only on the circumference. So for pi r length, how much mass do I have? I have capital circumference of the ring. On that circumference, the mass which I have is m by pi r, ठीक है, m by pi r. अच्छा, now what will be the length of this dm mass? The length of this dm mass will be dx. Simple, it is understandable, ठीक है. Small mass, small length, ठीक है. So for dx length, for dx length, for dx length, the mass will be m by pi r into dx, m by pi r into dx. Now what is this m by pi r into dx? This value is your dm. This will be your dm, ठीक है. Why it will be a dm? Because it is the mass of dx length, and dx length is having mass dm, ठीक है. And it is understandable, simple things. Just what we were doing is now done in angle, ठीक है. Earlier what we were doing in linear manner, now we are doing it along angle, that's it, ठीक है, nothing else. अच्छा, अच्छा, also can we find some relation between dx and d theta, ठीक है. Can we find some relation between dx and d theta? Yes, we can find a relation between dx and d theta. How? The arc length formula, L is equals to r theta. You know this is true for any arc length, ठीक है. So if I consider this red portion only, this red arc, ठीक है, this red arc only, then I can say that for this arc the length is how much? It is dx, it is dx, and the radius is capital R, that is already given to us, ठीक है. And the angle made by the arc at the center is how much? It is d theta, it is d theta. So I can replace dx as r d theta. Is it clear? ठीक है, I can replace dx as r d theta. Simple arc length formula I have applied, that's it, ठीक है. Arc length formula I have applied for dx and d theta, ठीक है. Instead of x and theta, I am using dx and d theta, that's it. You can say it like that, ठीक है. So dm, when I write dm is equals to m by pi r dx, now what I can write? I can replace dx as r d theta. So this will become m by pi r into r d theta, m by pi r into r d theta. So r will get cancelled. So dm will come out to be m by pi d theta, m by pi d theta. This is simultaneous calculation, that is why I am writing on the right hand side, ठीक है. Actual step is to calculate x only, ठीक है, x cm and y cm, ठीक है. अच्छा, so once I have the value of dm, है ना, now I need the value of x, ठीक है. I need the coordinates of this point, ठीक है. Let's take us another diagram, ठीक है. Let's make another simple diagram. You can understand what I am trying to say. ठीक है. Now see here, at this position at an angle theta, I had a very small element dm, ठीक है. That d theta is very small, so it is approximately at that point only. So dm is over here, ठीक है. Now this is x coordinate, this is y coordinate, this is origin. If I am able to calculate x comma y of this dm mass, then I can use it in the formula, Okay, I can use it in the formula because I have not yet calculated this x distance or y distance of this mass. Okay, I have not yet done this. This is x, this is y. So I have not yet calculated it, so I cannot use the x directly in the formula. So I have to calculate the value of x and y for this dm mass, or you can say for this point P. Okay, this point P will be the the elemental mass. Acha. How can we do that? We know that the radius is how much? The radius is r. Okay, we know that the radius is r. If the radius is r, you can use that component that resolution of vectors, okay, to find x and y. Okay, if you see, x can be written as r cos theta, x can be written as r cos theta, and y can be written as r sin theta. Y can be written as r sin theta. Hence, the coordinates of point P can be written as r cos theta, comma r sin theta. Yeah, is it clear? And now this is the basic. This is the basics of calculating the center of mass. ठीक है? अच्छा. Now, once you have x and y, okay, this is x and this is y. So now when you go to write xcm formula, okay, now when you go to write xcm formula, it is x dm upon integration dm, and ycm is what? Ycm is integration y dm upon integration dm. Okay, so in x formula replace x, in y formula replace y. Yes, I will do that. Just wait a minute. Okay, just let me solve this first. है ना? Otherwise the flow will break. Okay, so x is r cos theta, you can replace over here. Y is r sin theta, you can replace it here. And dm is common in both, so you have to replace it in both. Okay, you have to replace it in both. So let's calculate xcm. This is integration r cos theta. dm is m by pi d theta upon integration m by pi d theta. This is the formula for xcm, and formula for ycm will be integration r sin theta into m by pi d theta, upon integration m by pi d theta. Acha. Now are the limits? Just see here from the starting one. Okay. See, you are first of all here integrating with respect to theta. Okay, in the linear rod, we were integrating with respect to x. That is why I was talking about the limits of x. Here I am integrating with respect to theta, so I will talk about the limits of theta. Okay, limits of theta, that means theta will be starting from theta equal to 0. This is theta equal to 0, x-axis. Okay, you will keep on increasing the theta. It will 30, 45, 60, 90, and 120, and so on. It will keep on increasing 135, and finally where it ends? It ends at theta equal to 180 degrees. Theta equal to 180 degree. Hence, if you see the limits of theta, the limits of theta is from theta equal to 0 to theta equal to pi or 180 degrees. Okay, so let's keep it as pi only because that is in radians. Okay, so we cannot write 180 degree in general formula. We use it as pi only most of the cases. Okay, so let's keep the values in radians. So here when I write the limits, the limits will be from 0 to pi and again from 0 to pi. Here also 0 to pi, 0 to pi. Okay, after this it is complete calculation. Okay, it is complete calculation. M by pi will come out, m by pi will come out, m by pi will cancel out, m by pi will cancel out. Integrate both the sides, you will get the relation as xcm will come out to be 0. Okay, because integration of cos theta is minus sin theta, and when you replace the limits of 0 and pi in sine theta, sine 0 is also 0, sine pi is also 0, so 0 minus 0 will be 0. So everything will turn into 0 in xcm side. Okay, but in ycm if you calculate, you will get the value as 2r by pi. Okay, it is integration, you can do that. Okay, that is a different thing. Okay, we won't go into calculation. If you want, I can show you the integration. Yes, you want the integration? Okay, it is a very simple integration, I guess you can do that. अच्छा चलो कोई नहीं, let's do the integration only. ठीक है. So ycm is, see, in the numerator it is 0 to pi. R is a constant. ठीक है, R is a constant, so R will jump out. R sin theta d theta upon integration 0 to pi d theta. ठीक है, this is the thing which we are having. Now R is outside. Sin theta's integration is minus of cos theta. Sin theta's integration is minus of cos theta, and the limits are 0 to pi. Divided by denominator, integration d theta will be theta. Integration d theta will be theta only. It is like integration dx. Integration dx is x, so integration d theta will also be theta only. So it is from 0 to pi. It is from 0 to pi. Now r minus cos pi minus cos 0. ठीक है, upper limit minus lower limit divided by upper limit pi minus lower limit 0. ठीक है, minus of cos pi, if you see, cos pi is cos of 180. ठीक है, cos pi is basically cos of 180. Cos of 180 is minus 1. So minus of minus 1 will become plus 1. This will become plus 1. है ना? And minus cos 0. Cos 0 is 1. So minus of cos 0 is minus 1. So in the numerator it is r plus 1 minus of minus 1 divided by pi. So this thing becomes 1 plus 1, that is 2r by pi. This is ycm. This is the complete integration for your ycm. Okay, is it clear? है ना? ठीक है. So write this. So this is the value which you have to remember. ठीक है, that means what value I am talking about, that if I have a ring, then from the center of the ring, the center of mass, acha, I will show you that also, just a minute. From the center of the ring to the center of mass of the ring, of the half ring, the distance is how much? It is 2r by pi. Okay, this is x and this is y. Since xcm is 0, that is why only in y direction the center of mass is there. Okay, now about y, let's talk about y again. Okay, xcm. So again, if you see this r cos theta, r is constant, so it will jump out of integration. And so you will have what? You will have r integration 0 to pi cos theta d theta upon integration 0 to pi d theta. Okay, in the bottom, the integration we have that in y also. Okay, so in the denominator it is going to be pi only, so we don't have to worry about it. So it is r upon pi. What you are left with is integration of 0 to pi cos theta d theta. Okay, I have already integrated denominator in ycm, so I am directly using that value over here. Okay, not integrating again and again, double work. So r by pi, cos theta's integration is sin theta. Okay, its integration comes out to be sin theta. Limits from 0 to pi. Now, if it is from 0 to pi, replace the values of upper limit first. So upper limit sin pi minus lower limit sin 0. Okay. What is sin pi? Sin pi is 180. 180 sine of 180 means 0 degree. Sorry, 0. Value is 0. Okay. Sine of 180 is 0. And sin 0, if we are talking about sin 0, that is also 0. Okay, so this becomes r by pi 0 minus 0. So it is r by pi into 0 only. 0 minus 0 is 0. So 0 into anything is 0. Hence it is 0. Okay. And this comes out to be the value of xcm. Okay, so these are the two basic integrations which we have used here. That is integration of sine theta and cos theta. Okay, you have to why we did this. अच्छा अच्छा ठीक है coordinates part है ना just a minute ठीक है why we did this integration why we did this derivation is that you should understand the importance of remembering things ठीक है many of the students think that कि, when I integrated rod sir it is easy we can do that in exam also ठीक है that is not possible ठीक है that is not possible है ना in center of mass at least for uh, half ring ठीक है semi ring hemisphere all these values you have to remember ठीक है there are not much values there are 4 5 values है ना to know so that will be easier to remember ठीक है so you have to uh, just for showing the importance of remembering things in physics ठीक है not everywhere I am telling you to remember everything ठीक है only in some places I will tell you to remember this and that and this and that ठीक है so that thing at least you should remember ठीक है many of you forget it I know you will forget it but try to make a table and keep it somewhere in your room somewhere ठीक है so that whenever you see at least it will be there in your mind ठीक है अच्छा about the coordinate part ठीक है about the coordinate you wanted the coordinates so see this element ठीक है this small dm element was at an angle theta ठीक है this is what we had done that we had taken this element small element at an angle theta from the x axis ठीक है so this is a very large diagram this is a very enlarged diagram ठीक है the actual diagram is very small this dm is just a point ठीक है it is just a point on the ring है ना so I can say that it is at an angle theta only ठीक है the dm is at point p which is at an angle theta from the x axis ठीक है now if theta if p point is on the ring its coordinate is x and y then how can you represent x and y ठीक है x will be this vector and y will be this vector ठीक है you can understand this in the terms of vector also or you can understand it using triangle also both I will tell you now ठीक है this is 90 degree ठीक है this is your r vector this is your r vector so the r vector has two components ठीक है if you resolve r vector ठीक है it will be having two components one is r cos theta that is the horizontal component and the other will be r sin theta that is your vertical component ठीक है so horizontal component is equal to x only ठीक है will be equal to x only and your vertical component will be equal to y so r cos theta is equals to x and r sin theta is equals to y you do it like that or if you want you can draw a triangle over here you can see that the triangle formed over here is x y and r you can see that it cos to r whichever is suitable to you ठीक है if you are comfortable with vector components use that is easier to remember or if it is from the triangle you can use it from triangle also that is also easy to remember ठीक है whichever is suitable to you you can use that ठीक है ना so uh, some steps are there ठीक है if you want you can remember those steps like this step was there dm step this dm calculation is there that is something which is unique new calculation for you so you can remember these things ठीक है, रेस्ट इंटीग्रेशन एंड ऑल इज ठीक है, इट इज यू आर यूज्ड टू दैट इंटीग्रेशन एंड ऑल. ठीक है. So we have calculated the value of your center of mass for a half ring. ठीक है. Now you have to remember this value. ठीक है, that the center of mass of a half ring, of a semi ring, is at a distance of 2r by pi from the center of the ring. ठीक है. So what I will do is I will make a table over here. ठीक है, I will make a table over here. Not exactly a table, it is a kind of a list you can say. ठीक है, for which you have to remember the values. ठीक है, so let's just write it as a note. ठीक है, that will be better. So first is your rod. ठीक है, uniform rod. ठीक है, you can write a uniform rod over here. Let's write uniform rod. Uniform rod. ठीक है, for uniform rod, here the center of mass, if we are talking about, ठीक है, if its length is L, its center of mass will be L by 2 at a distance L by 2. It will be at a distance L by 2 from one of the ends. ठीक है, this is a bit easier to remember. ठीक है, that it will be at the midpoint. Second, suppose you have a uniform ring. If you have a uniform ring, so this is the ring. ठीक है, this is a ring and this is the center. So this center only is your center of mass. The center only is behaving like the center of mass also in case of ring. Okay. Third is half ring, semi ring, semi uniform ring. Semi uniform ring. Okay, this is the ring. Okay. Its radius is r and O is the center. So from the center we have just calculated that the center of mass, okay, it is not to scale. Scale, it won't be much writing. Pi. Okay, from the center of the ring, the center of mass will be shifted towards the ring by a distance of 2r by pi. Okay. Acha. Next is your uniform solid sphere. ठीक है, uniform solid sphere. If you have a solid sphere, है ना, everything is filled over here completely with mass, then again the center and the center of mass are at the same point, that is origin. ठीक है, at the center of the sphere only, that is same, you know this. ठीक है, this is standard, these are standard. ठीक है, you know these standard things. ठीक है, fifth, uniform hollow sphere. Hollow sphere, again if it is a hollow sphere, ठीक है, if it is a hollow sphere, yeah, let it be this only, it will confuse, you will confuse with the ring. If it is a hollow sphere, for hollow sphere also your center and center of mass will be at the same point. Okay, again for a hollow sphere also the same thing is happening. Next, uniform.
Sir, scroll up.
Solid, yeah, just a minute. Yes. ठीक है, okay, wait a minute. Yes, ठीक है. Next is uniform solid hemisphere. Hemisphere, ठीक है, if you're having a solid hemisphere, ठीक है, this is your hemisphere, this is the center of the hemisphere. So for a solid hemisphere, the center of mass again will be shifted upwards, ठीक है, but now the distance between the center of mass and the center of the of this hemisphere will be 3r by 8. 3r by 8, you have to remember this. ठीक है, these are all coming from the same method. ठीक है, same integration you have to do. ठीक है, the complete integration what we had done for the ring, but this time it is for hemisphere, it is for solid thing. ठीक है, the shapes are changing, so the values will also be changing, the integration will also be changing. ठीक है, so that is why we have to, instead of calculating it every time, ठीक है, it is better to remember these things. ठीक है, if you do some questions ना, if you do uh, around 10-15 questions, ठीक है, of the center of mass, you will remember these values itself. ठीक है, next is uniform hollow hemisphere. Uniform hollow hemisphere. ठीक है, this is solid, everywhere it is mass. Now this is hollow. So for hollow hemisphere, or you can say shell, ठीक है, hollow hemispherical shell, the distance comes out to be r by 2. ठीक है, this is very easy to remember, r by 2. Next is 8th, that is uniform solid cone. ठीक है, if it is a cone. Fifth one is hollow sphere, complete hollow sphere or complete shell, you can say. ठीक है, don't worry, I will give you time to write. ठीक है, just let me write it once. ठीक है, now this is a cone, solid cone. ठीक है, it is a solid cone. This is x, this is y. ठीक है, from the center of the base. ठीक है, for a solid cone, from the center of the base, the center of mass for a solid cone, ठीक है, it is at a height of h by 4. And what is h? H is the complete height of the cone, vertical height. ठीक है, this is the way to remember solid cone. ठीक है, center of mass of a solid cone, that along the perpendicular line, ठीक है, you can see that this is the vertical axis of the cone. ठीक है, on that axis only, ठीक है, if the height is h, then the center of mass will be at h by 4. It will be at h by 4. Ninth is for uniform hollow cone. Hollow cone. ठीक है, now if your cone is hollow, ठीक है, if your cone becomes hollow, still the height is h only, but now the center of mass will be at a distance of h by 3 from the center of the base. ठीक है, it will be at a height of h by 3. So it is easy to remember, hollow h by 3, solid h by 4. That's it. ठीक है, it will be more further away. ठीक है, अच्छा, then almost all are done. Anything remaining? ठीक है, almost all the shapes which you have to remember, ठीक है, are done, है ना? So you have done rod, ring. ठीक है, so just write this. ठीक है, अच्छा, disk is remaining. Disk is left. 2 more are there. 10th is uniform disk. ठीक है, so if disk is there, So again, for a complete disk, your center of circle and center of mass are at the same point. Okay, no difference in that. Okay, that is the same point. Acha. But if it is a uniform semi disk, if it is a uniform semi disk, then again, if this is the center, radius is r, then the center of mass will be shifted by a distance of 3r by 2 pi. 3r by sorry, 4r by 3 pi. 4r by 3 pi. Sorry. It is 4r by 3 pi. Okay, for a semicircular disk, semi disk. So these are few of the values which you have to remember. Okay, see, many of the values you must be knowing, like let's see, for the rod you must be knowing L by 2. For a uniform ring, you know it is the center only. Okay, 1 2 4 6, okay, 10, these all you know already. Okay, these are standard, geometrical centers, you know these already. Okay, the ones which you have to remember is the new shape, that is the hemisphere, the half one, semi ring, hemisphere, hemishell. Okay, all of these you have to remember. Okay, cone one is the new one, that is why it is I'm not considering that you know the center of that. But still, you must be having some idea that the center of mass of the cone is at a solid cone is at a distance h by 3, sorry, h by 4. ठीक है, the meridian, ठीक है, it is the connection of the meridians, you can say. ठीक है, so that is these are the values which you have to remember.
So please scroll down.
Yes.
So
So
what is
once
that?
again, can you show the third one?
Solid hemisphere.
What?
So is it 3r by 8?
Yes, it is 3r by 8. Let me write here. YCM here
Okay,
is
sir.
r by 8. Okay, that gets mixed into that. No problem.
So can you show
Yes.
the third one?
Yeah.
Thank you, sir.
Okay. Now see why I am saying you to remember these values. Okay, let's see a question based on this. Okay, what kind of a question can be asked? Okay, regarding the center of mass only. Okay, see, actually this center of mass concept will be used everywhere. Okay, it can be used anywhere. It can be used in electrostats. It can be used in rotational motion, and anywhere it can be used. But why it is important to remember? Okay, if it comes in just for center of mass question, then how to solve it? So you can see here that let's say let the question be that okay, this is the combination of two different shapes, two 3D shapes. One is hollow sphere, hollow hemisphere. Let's write it as hemisphere. And another is solid, or you can write it as hollow, better. Hollow cone. Okay, that you have two different shapes. That is, one is a hemisphere, other is a hollow, and mass of m, and the mass of hollow cone is suppose 3m, just for example. Okay, what they will be asking is that if this height is r and this radius is also r, then what is the where is the center of mass? Okay, they will be asking about the distance of the center of mass from origin, from O, from origin. Okay, this is the question. You have to find the center of mass of this system from origin. Okay, so how to do this? Okay, very simple. If you remember the values of the center of mass, it becomes very easy. Okay, for now you can see the table and tell me. Okay, so tell me, what is the center of mass of the hollow hemisphere? Yes, anybody? Just look at the table. Just look at the values. Just now I have written
R by 2.
r by 2. Very good. R by 2. So the center of mass of 1, I can say, let this be 1, let this be 2. So CM1 will be at a distance of r by 2 from the center. Okay, it will be at a distance r by 2 from the center. And what about hollow cone? Where will be the center of hollow cone be?
H by
H by
3.
3.
H by 3. H in this case,
H by
my
3.
H by 3. In this case, in my case, the h becomes r, so it is at r by 3. Very good, no problem. Okay, center of mass of second shape is at a distance of r by 3. No problem. Okay, now see, what does center of mass mean? Center of mass means that I can reduce this complete shape, this complicated figure, into this two points, two center of masses, cm1, cm2. That's it. One is at a distance r by 2, other is at a distance r by 3 from the origin. And the mass at center of mass 1 is how much? It is the total mass of the hollow hemisphere, that is m. Mass at the center of mass 2 is how much? It is 3m, because that is the concept of center of mass, that you remove the complete shape and replace that complete shape with a point of same mass. You assume the total mass to be concentrated at that point. Okay, so what I did is I removed the complete cone and I concentrated the total mass of it at point of cm2. That is 3m mass is concentrated now at cm2. Now it is just your center of point object, the first. Okay, so it is in y-axis. You can write the coordinates 0 comma r by 2 and 0 comma minus r by 3. Okay, these are the coordinates of cm1, cm2. And what you can do is you can write ycm, that is m1 y1 plus m2 y2 upon m1 plus m2. Simple. M1 is capital M, M1 is capital M, Y1 is R by 2, M2 is 3M, Y2 is minus R by 3 divided by M1 plus M2, M plus 3M. So whatever this comes out on calculation is your final result. Okay, did everybody get this? Okay, this is how you solve whenever you have 3D figures. Okay, if you have 3D shapes, this is how you resolve it. This is how you solve such kind of questions. Okay, is it understood?
Yes, sir.
Okay, so this will come out to be mr by 2 minus mr upon 4m. So and also gets cancelled. So in the numerator it is r by 2 minus r, that is minus r by 2 by 4. So this should be minus r by 8. Okay, that means the center of mass of the total system, yes, of the total system is towards the cone. It's towards the cone. That is understood. Okay, ycm is minus r by 8, somewhere over here. It is minus r by 8. Center of mass is somewhere over here. It is understood because the cone has more mass. So obviously the center of mass will be towards the cone, okay, rather than sphere, hemisphere. Okay, it is understood that. Okay, so if you would have gotten a positive answer, that means you had done some calculation mistake in the way. Okay. Acha, let's see another problem. Okay, this was a bit,
So can you scroll down?
yes,
Yeah, thank you.
yes.
Yeah, done, sir.
Okay. Now see, this was a very random question. Okay, in many of the cases, such kind of shapes are very rare to be seen. Okay, it is not a very common type of question to be asked that you have a hemisphere connected to a cone. Okay, that is a very uncommon kind of figure shape. So that is not asked many of the times. Most of the times you will be stuck with either a disc, okay, or a ring, or combination of rods. Okay, such kind of thing will be there. So let's see that if we have, suppose rod is there like this, mass m, length l, and another rod is kept like this, mass is 2m, length is l. So again you have to find the coordinates of center of mass. Okay, from the center of origin, from the origin, that is o. Okay, so try yourself once, then we will discuss it. Okay, take time, take 2-3 minutes. Try yourself once, then we can talk. We can discuss.
Scroll up.
Yes.
So the previous part I want.
Previous question you want? Achha.
Yes, sir.
Yes. Anybody getting the answer? Tell me cm. What should be the value of x cm? If you are getting the value of x cm, y cm will be correct only. You don't have to worry about it. I can guarantee you, you will get it right. Yes, so much time. Very good, very good. L by 6 and L by 3 is the answer. Nice. L by 6, L by 3 is the answer. Okay, so let's see. Very easy, simple. Okay, rods are very easy. Okay, that is why they are mostly asked in exams. Okay, other shapes are very less used. Okay, they can make a, if they want to make a difficult question, they can use it, but they don't use it to make keep the paper level, okay, moderate, and you can say average. So see, when rods are there, simple. The center of mass. Let's take this one as one. Okay, the bottom one as one, and this one as the second rod. So the center of mass for this rod, cm1, will be at a distance of l by 2. So what can be the coordinates? Coordinates will be l by 2 comma 0. Simple. cm1. And the center of mass of the second rod will be cm2 at a distance again l by 2 only. L by 2 only. ठीक है, its mass has increased, but this doesn't mean that the center of mass position will change. ठीक है, still the cm2 will be at a distance of the l by 2 only. So if you write the coordinates, x coordinate is 0, y coordinate is l by 2. ठीक है, so now you can write xcm. xcm is what? m1 x1 plus m2 x2 upon m1 plus m2. M1 is how much? Capital M. X1, this is x1, this is y1, this is x2, this is y2. So m1 is how much? L by 2 plus m2 is how much? It is 2m. ठीक है, the second rod is of mass 2m into x2. x2 if you see is 0. x2 is 0 divided by m1 plus m2. m1 plus m2. So this becomes, if you solve this, this will be ml by 2 on the numerator, 3m in the denominator, cancel out, this will become l by 6. ठीक है, ycm, if we are talking about ycm, same formula, m1 y1 plus m2 y2 upon m1 plus m2. m1 is again capital M, but this time y1 you can see that it is 0 plus m2. m2 is how much? It is 2m, but this time y2 is l by 2. y2 is l by 2. ठीक है, divided by m1 plus m2. So this comes out to be, this 2 and 2 will get cancelled. So in the numerator it is ml upon 3m. So mm gets cancelled. This comes out to be L by 3. So xcm is L by 6, ycm is L by 3. So you can say that the center of mass will be somewhere here. The center of mass of the system will be somewhere here, L by 6, comma L by 3. This is the center of mass of the system. ठीक है, so another theoretical question which can be formed here is that, is it necessary for the center of mass to be inside the solid, inside the volume of the solid? ठीक है, so that is incorrect. ठीक है, you can say that it is not compulsory for the center of mass to be inside the solid. Center of mass can be outside the solid also, like in this case. ठीक है, the center of mass of this system is where? It is somewhere in outer space. It is outside the rods. It is not inside the rod. ठीक है, center of mass is over here. So that point is outside the rod. ठीक है, center of mass is not necessary that it should be inside the rod, inside the solid. ठीक है, ठीक है, hope it is clear. So ठीक है, we will stop here. That's it for today. ठीक है, I don't know when sir will be coming. He is not feeling well till now. ठीक है, but doesn't matter. ठीक है then. That's it for today.
Thank you, sir.
Thank you.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you, sir.
Sir,
Yes.
Thanks.
sir, could you show that values which were
Which value?
given? Uniform disk.
अच्छा, center of mass, this.
Yes, sir. Of a uniform disk.
Yes, this is the uniform disk.
Sir,
Yes.
I think the screen is frozen.
अच्छा, is it now?
The question only, still not that last question only is showing.
अच्छा, just wait a minute. It will come. It will come.
Okay, sir.
ठीक है, everybody is leaving, so most probably it will clear out. ठीक है, so don't worry, it will show. Yes, now is it visible?
No, sir. Still now the last question only. Now it came. Now it came, sir.
हाँ हाँ, ठीक है. Right.
Thank you, sir.
ओके, ठीक है, so that's it.